Hello, fifth period. Sorry I'm not here today, but hopefully this is helpful. Today we're going to be looking at 6.3.1, can I solve without substituting? So we're solving systems using elimination. In this chapter, you have learned the equal values method and the substitution method for solving systems of equations. But are these methods the best to use for all types of systems? Today, you will develop a new time-saving method for solving a system of linear equations when both equations are in standard form, aka ax plus by equals c. Problem 6-79. Jeanette is trying to find the intersection point of these two lines. Our first equation is 2x plus 3y equals -2. And our second equation is 5x minus 3y equals 16. She has decided to use substitution to find the point of intersection. Her plan is to solve the first equation for y and then to substitute the result into the second equation. Use Jeanette's idea to solve the system. All right, so first we're going to solve the first equation for y. Our equation is 2x plus 3y is equal to -2. We want to get this y value all by itself. So first we're going to isolate that term. To get the term with y by itself, we're going to subtract out this 2x. And since we did it on one side, we have to do it on the other side. Anything minus itself becomes 0, so all that's left on the left here is this 3y. And then we have -2 minus 2x. These are not like terms because they do not both have x, so we cannot combine them. Our goal is still to get this y by itself, so we're going to divide by the coefficient, in this case 3, and we have to divide every term in the equation by that 3. When we do this, those 3's cancel out, and we will be left with our single positive y. And then we have -2/3 minus 2x over 3, or 2/3 x. All right, so we have this y equals equation over here, and then we also have a y in this equation over on the right. Since this is a system of equations and we want this y and this y to be the same, we can do this. All I did was replace the y that was here with what y is equal to. So next, I'm going to distribute the -3 to all the terms inside the parentheses. Because I have a -3 right here and a -2/3 right here, I'm actually going to turn that into a plus sign. Again, because we have a negative times a negative. And then the 3 times the 2 is going to be on top with our 3 in the denominator. We have, again, another negative times a negative over here. So this is also going to turn into a plus. And we get a 3 times 2 again. Still all over 3. But this one has an x. We haven't done anything to the 16, so that's still 16. So there we go. What's nice here is we have some things that will cancel out. So we can cancel out those 3's because they're a common factor, just like we were canceling out x's when we thought about our exponents. That happens again over here. And so ultimately, we're left with 5x plus 2 plus 2x. And that still is equal to 16. Now we're going to combine like terms. So we have our 5x and our 2x, And those are like terms because they both have the same variable to the same power. 5 of something plus 2 of something, that gives us 7x. We haven't combined the 2 with anything, so it's going to hang out. And everything still equals 16. Now we want to isolate x, so we're going to subtract 2 from both sides. Anything minus itself is 0, cancels out. And we're left with 7x is equal to 14. Our last move then is to divide by the coefficient. If we do it to one side, we do it to the other. 7 and 7 cancel each other out, just like the 3's did up here. And we're left with x is equal to 2. Now, that's just the x value. We still need to find the y value. So I'm going to take one of my original equations, actually, and I'm going to say, let's write in purple. I'm going to take one of my original equations and say 2 times 2, because I'm taking this 2x. Now we know that x is 2, plus 3y is equal to negative 2. Now I'm just going to solve for y. 2 times 2 is 4, plus 3y, all equal to negative 2. We want to get the y term by itself. Oops. So we're going to subtract 4 from both sides. 4 minus itself cancels out. Negative 2, going 4 more to the left, subtracting 4, and we get negative 6. And that's still equal to 3y. Last but not least, we're going to divide by the coefficient on both sides. And we get y is equal to negative 2. So, with our x value of 2 and our y value of negative 2, since this is an abstract problem, meaning it's not a word problem, we're going to write our final answer as a coordinate. The x value is 2, and the y value is negative 2. That was an awful lot of work, though. So let's look at solving this system in a much faster and simpler way. Here's our system again. It's the same system, 2x plus 3y equals negative 2, and 5x minus 3y equals 16. The really important thing here is this is a positive 3y, and this is a negative 3y. Because we have opposite coefficients, so we have a positive and a negative with the same absolute value on the same variable, we can streamline this process. We do not have to go all the way to slope-intercept form. We can simply add the equations together. So, when we add our x's together, we have 2x plus 5x, and that gives us 7x. Right here, we have 3y plus negative 3y. That's going to cancel out. Those eliminate each other. The equal sign stays where it was. And lastly, we have negative 2 plus 16. That's like saying 16 minus 2, so that's 14. So, what took us many, many steps and lots of algebra to get to here in our previous method, now we're just at 7x equals 14. We'll divide both sides by the coefficient on our variable. In this case, it's 7. And we're left with x equals 2. So that part's way faster. Now, we need to keep going. We do not have our solution to the system yet, because if we have an x, then we need a y. So I'm going to pick this equation this time, just for fun. And I'm going to say 5 times 2, because now I'm replacing what was the x here with what I got for x, minus 3y, that stays the same, equals 16. Then I solve. 5 times 2 is 10. We want to isolate our term with y, so I'm going to subtract 10 from both sides. When you do this, be very careful. This was a negative 3y. It's still going to stay a negative 3y even when this 10 goes away. So we get negative 3y. 16 minus 10 is 6. Then we divide both sides by the coefficient. This coefficient is negative 3, so that's what we're dividing by. Anything divided by itself is positive 1, and we again get y equals negative 2. So now we are at the same solution, where x is positive 2 and y is negative 2. Personally, I like that method a whole lot better. So if you see opposite coefficients, that's your clue. Maybe you can just add those equations together. Let's take a look at another problem. So Annie was going to use this elimination method, and she was ready to add the same value to both sides of the equation to eliminate the x terms when she noticed a problem. Both x terms are positive. So with your team, figure out something you could do. We're doing this as an ed puzzle, so come up with one thing you could do or that you think you could do so that you would still be able to add these equations together and it would eliminate the x. Cool. Now, some of you may have come up with the idea of subtracting. That will absolutely work. However, all of these numbers right here are positive. So subtracting is going to be fairly straightforward and you're not super likely to make little mistakes. If there were any negative signs, subtraction can get quite tricky. Not difficult, just tricky. It's very easy to make small mistakes. So we are actually going to multiply one of the equations by a negative so that we can create opposites and add. So what I'm going to do is say I'm going to multiply this whole thing by negative 1. So we're going to multiply the 2x by negative 1, the 3y by negative 1, and the 5 by negative 1. And then I am going to rewrite my system. You are not going to want to do this, but it will save you a lot of wrong answers and a lot of reassessments. So I just copied over the first equation. That we didn't change at all. This next equation, all we've done is change the sign on all of the terms. Now, we do have opposites. So we have positive 2 and negative 2 on our x's, which means we can add these together and they will cancel each other out. They will eliminate each other. So 2 and negative 2 added together make 0. 7 plus negative 3, or 7 minus 3, that's going to be 4y. And last but not least, 13 plus negative 5 is the same as 8. Now we keep going. We'll divide both sides by the coefficient. This time it's 4. And we get y is equal to 2. So we solved for y first this time. Totally fine. Now we need to find x. So we can pick either equation. I'm just going to go with the top one. And I'm going to say 2x plus 7. And then instead of y, I'm going to write in parentheses a 2. That's still going to equal 13. And then we go from there. So 2x plus 14 is equal to 13. We're going to subtract 14 from both sides. And we get 2x is equal to negative 1. And lastly, we'll divide by the coefficient, and we get x is equal to -1/2. Are we done? Right. We still need to write our solution as a coordinate point. And x always comes first. So that's our -1/2. And then our y value is +2. Let's try a couple more together. So we're thinking about elimination because we see two equations, both in standard form. Do we have opposite coefficients on the same variable? We do. We have negative x here, so -1x, and we have positive x here, so that's +1x. What should we do next? We should add them together. So I'm just gonna, oops, that's a highlighter. I'm gonna put the plus sign in. I'm gonna draw my addition line. Then I'm gonna start adding. 2 plus -3 gives us -1y. And if you just wrote -y, that's great. The negative x and the positive x will cancel each other out. So they are eliminated. And that's going to equal 5 plus -9, which is -4. Now, we want +1y, so we still divide by the coefficient on our variable on both sides. And we get y is equal to 4. We found y. Now we need to find x. So I'm going to use the top equation. No particular reason. Either equation will work. So I'm going to say 2, and then instead of writing a y, I'm going to put this 4 in. So again, just to confirm, I got this 4 because y was equal to 4. And so I'm replacing that y with a 4. Next up, I'm going to say minus x, and then that should equal 5. 2 times 4 is 8, minus x equals 5. I want my x by itself, so I'm going to subtract 8 from both sides. This is going to cancel out, and I'm going to get -x. Remember, if it's minus, it doesn't just disappear. And 5 minus 8 is -3. Then, since I want a positive x, I'm going to divide both sides by -1 to get rid of that negative sign. And I get x is equal to 3. So my final step is to write my solution as a coordinate point, 3, 4. X, then y. Here's another one to try. Give you a hint, we got to do some rearranging. Okay, so what I did was, this is positive 4y, this is -4y. They weren't one right over the other, but I'm allowed to move things around that are being added. So I just swapped the position of the -x and the positive 4y, and I put that -x first, and then I added the 4y second. So now everything lines up nice and neatly. Great, now let's solve. Last but not least, we can see that we do not have any opposite coefficients. Everything is positive. Let's change that. Doesn't matter which one you make negative, so this time I'm going to make the top one negative. I'm going to take this whole thing, and I'm going to say times -1, times -1, times -1. And I'm choosing -1 again because I can see that this is 4, and this is 4. So if I make one of those a -4, I have what I'm looking for. Once again, I'm going to rewrite so that I can keep track more easily and say -3x minus 4y is equal to -1. Don't forget about this. This one is often forgotten about when you're multiplying. Then the bottom equation is going to stay exactly the same. Now that we have opposite coefficients, 4 and -4, we can add these together. Try solving this one on your own, and then use this video to check your answers.